Happy New Year, everyone, and welcome to the first National Stock Assessment Science Seminar of the year. My name is Bailey, and I coordinate this monthly seminar series that highlights interesting advances and topics in stock assessment science. Today, we are really excited to have Dr. Kelli Johnson with us. Kelli is the project lead for the Fisheries Integrated Modeling System. She earned her master's degree from Simon Fraser University in 2012 where she quantified the special use of shipping lengths by blue whales. And shortly after, she began her PhD with Dr. Andre Pang. And 5 years later, she joined the Northwest Fisheries Science Center. Most recently, she transitioned to the Office of Science and Technologies Assessment and Monitoring Division as the project lead for FIMS. So in today's seminar, she will guide us through the timeline of FIMS, a next generation framework for stock assessments. Without further ado, I'll turn it over to Kelli, and thank you all for joining us.
Welcome, everyone. And I work with this large group of people shown on the screen in the Fisheries Integrated Modeling System. And within this team, so each of the pictures are people on the FIMS implementation team, there is a huge range of expertise from things ranging from template model builder in R and C++ to Git and GitHub Actions and fish life history, fisheries management, statistics, running Bayesian models in STAN, spatially explicit models with Gaussian Markov random fields, economics, multi-species models, the list goes on. It's pretty amazing the amount of knowledge within this group. For example, when I started with FIMS, I didn't know C++ at all. I knew some Fortran, which most of you will know that's only because Andre was my supervisor. But now I can at least pattern match in C++. Additionally, I had never used STAN, but others on the team had. And with this team comes a great amount of knowledge sharing. And so focusing on me, Bai gave a pretty good introduction to that, but I wanted to go into it a little bit deeper. So at the Northwest Fisheries Science Center, I mainly authored stock assessments for sablefish, lingcod, and Pacific hake. But at the core of everything that I do, I really love reproducible research and anything that's related to making other people's jobs easier. And in 2021, which was the beginning from my side of FIMS started a little bit earlier with the CAPM research symposium that happened in New Zealand. And there were lots of presentations there on next generation stock assessments. And then there were lots of presentations to funders and to try to get everything up and going. But I was asked and others were asked in 2021 to be part of the team. So I've been on the team since then. And in June of 2024, I signed up for a detail to take over as the FIMS project lead on a temporary basis for 6 months. I loved it, which was slightly surprising. And so I decided to apply for the permanent position, and I was awarded the position in November of 2024. And I, like many others, are extremely committed to bringing the science centers together with this common framework called FIMS. And so at the backbone of FIMS, you can see the actual backbone of the logo is the words FIMS. We have C++ that's used to code the modules. So I have an example of just a very, very tiny piece of C++ code here on the left-hand side of the screen. And then we use R to parameterize those models. And I have two examples of some R wrapper functions that users can create default parameters given their data, and then also initialize a model. And with that initialization, that puts things in your memory. And then template model builder, also known as TMB, can be used to fit that model to your data. And then NLM-INB, which is a function inside the stats package in R, can be used to estimate the parameters as well as other functions. And then R is used to post-process the results, for example, using ggplot. And so it's really a network of all different kinds of software that comes together to create this framework called FIMS. But the most important part of FIMS is, like Isaac Newton mentioned, if I have seen further, it is by standing on the shoulders of giants. FIMS doesn't do a whole lot that's really new, novel, or original. Population dynamics, you can only do so much with the equations that are there. And so we're not going to lie and say that the age structure population dynamics that are in FIMS are any different than any of the age structured models activity function. It's taking the best of each of these modeling frameworks, or at least what we think is the best part, and putting it into a single framework. And so the beauty of it really comes from when you have a surplus production model, you have to use one framework. And then when you want to run an age structured model, so you get a little bit of age data, then you have to switch to an entirely different framework. When you switch to an entirely different framework, you often have to change your inputs. So the data inputs are not the same, or the way you run the model is not the same. This is where we really want to break down the barrier. So we want to really have FIMS be a modeling system where you can build different types of models. And you're already familiar with how the data needs to be input into your model. You're already familiar with how the output comes out of the model and the post-processing that's needed for that. And so we've talked to a lot of developers, not only within the United States, but also internationally, such as you'll see CASL 2 is on there, and Gadget, a multi-species model. And so we really want to move beyond just like the frameworks that each of the science centers use. We want to think about what is best for all of the scientists. And this comes back to my real love of science and making things reproducible, making things easier for others. So again, we're not making new population dynamics models. We're just trying to bring everyone into a level playing field where it's easier to talk to your neighbor about it because you have the same data inputs. And so this talk is supposed to be largely about the timeline of FIMS, but I thought that some of the background would be helpful before going into the timeline. And then in the very beginning, I talked about all of the range of expertise that everyone brings into FIMS. I am not the most well-versed in Bayesian models, nor in statistics or population dynamics equations. I muddle my way through most of that decently, but where I feel like I really help people is how to use a version control system. So we use Git and GitHub. I also like R a lot, but I feel like a lot of other people do things slightly better there. And so I thought, how should I show the timeline? Well, I should show it in the way that I'm most comfortable with it so I can explain it the best. And so I created this timeline that's a shortened or condensed version of our Git commit history to delve into where we started in 2022 with our first commit in January. And then all the way at the very end of this timeline is today, the second January, where we have version 0.3.0. And so I'll zoom into different parts of this, but this is just trying to explain where we've come from. And so we started, like I said, in January of 2022 with our first commit. And these three commits here are really the backbone of what we did in our first version 0.1. So we started an age-structured assessment model, and we included the C++ code that was necessary to build all of the modules at that time. We kind of, in my mind, revolutionized how you input data into a model, in that instead of having different input files or having different data structures in different formats, FIMS uses a single data frame where it's in a long format. And so you have 1 year of ages from one fishery, from one year, and then the fishery, and then that age. And so the proportion that it was of that age, that's just one row. And then your next row, you have a different age for the same fishery for the same year. And we do that for each of the data structures. And the beauty of it is when we have new data structures in the future, they can easily be migrated into that. And we also integrated into the code a lot of testing. So we use Google Tests to test the C++ code, and we use the R package test that to test the R code. And then there were a lot of other things, but those were the main highlights, in my opinion, from version 0.1. And then in July of 2023, we moved on to version 0.2, where we created a FIMS vector class in C++. And the amount of testing that we did on the C++ code increased, as well as we brought in code coverage. So we know how much of our code is being tested. And then with each commit, we try to keep that around 75%. And we also implemented a logging feature where when you run a model, it will write log files to the disk so you can go back and see what you did or where you potentially have some mistakes. So version 2 ended in December of 2023, and then we started on the version that will be released later today. And with that, we started using branches a lot more, where instead of bringing stuff back into the main branch, this yellow branch here is called dev. And then all of our recent changes from version 0.2 went into dev before, like today, they will go into main as one commit. And so the things that we brought in version 0.3 that I'm most familiar with, because for half of this time I was the FIMS project lead, we have FIMS that fits to length data now, where it uses an age to length conversion matrix, much like how they do it at the Alaska Fisheries Science Center. And we have package data called data 1. And in that data, you can easily access the data by installing FIMS as a package, as an R package, and then you can run a model with that. It includes both age data, length data, and the conversion matrix to go from lengths to ages. We additionally made a C++ parameter vector to allow for time-varying parameters. And then the item with respect to R, it was pretty big, the changes that we made, where before it took hundreds of lines of code to run a model because you had to set all of the specifications for your C++ modules. And now we have wrapper functions where you can take your data set and it'll look inside of that data and see what kind of data you have and create a default parameter set for you. You can update that parameter set using the update_parameters function, and then you can initialize your C++ modules with a wrapper. And it might not sound like a lot, but before, like I said, it took hundreds of lines of code to run a model, and now you can run a model in less than 60 lines of R code. And at the moment, we require to run a model that all combinations of data and years and fleets are available. And so before, users had to put in, so if you were missing year like 1990, you would have to put in all of the data for 1990 with a value of -999 for that. Now we additionally have wrapper functions that'll do all of that for you, so you can have holes in your data, and that's not a problem. And then we have another function that will run the model for you. And then you can specify how many times you want the optimizer to optimize it to try to find the best solution. That also happened in this milestone. And then another with respect to the R package is there's an R package called CLI, and we use CLI to print messages to the screen. And sometimes those messages can get annoying. And so we have a global verbose argument, and you can set that before you run a model, and it'll turn off all of the messages, or it'll only give you warning messages, and it will always give you error messages. And that makes it nice for when you're running models in the cloud, or when you say you're rendering it to a vignette and you just don't want to see all of that output, but you don't want to have to do it in every single function call that you are passing to R. We also updated the logging system, where now we can save errors, warnings, and just information from both the R side and the C++ side. And we implemented some initial infrastructure for random effects. And the random effects are not complete, but the next milestone, hopefully, will have more options for random effects. There was a lot of changes to the C++ code that was needed for that. And then a big thing for us was because we use TMB in a non-standard way, it was difficult to find out in your vector of parameters which parameter was which, like which parameter is number one versus number two. Because of the modeling framework that we have, you can move the modules around. And so now those parameters are named, which is really helpful for the post-processing. And then also down here, we have this green branch that we have the milestone that's completed and will be merged up into main later today, like I said, but this green branch is still hanging down here. And that pertains back to that word cloud that I showed in the beginning, where there was different surplus production models in there. There were age structured models, and this green branch is a surplus production model that we have in the works, and it's just not finished for this milestone, but it'll move on to the next milestone where you can use the surplus production model for when you don't have age data. Or you can also use a surplus production model when you do have age data, but you just want to use a surplus production model as a diagnostic. And like I said before, that will be really nice so that you don't have to change the way that you're inputting your data into the model. The output will still look the same. So you just change some of the modules that you pass to your final initialization, and then you have a surplus production model. And so now we're going to talk about the timeline of the future, where the future really starts today for FIMS. Everything I talked about is code that's been implemented. And then this is the timeline for going forward, where we have 6 different branches. We have our main branch, and then now the yellow branch I already talked about is the surplus production model. We have a branch that's like the surplus production model has already been started that relates to CPUE indices. And then below that, we'll be merging everything into dev. And we also are going to do some work with TMB, where right now we're using TMB CPPAD, and we're going to switch to TMB AD, where that will allow for different modules that are in the C++ code to be used by our TMB. And then a big feature that we're going to work on in the immediate future has to do with discards. So in FIMS at the moment, you have to assume that discards are either included in your catch and in your age compositions, or you input them as another fishery. And sometimes the problem with another fishery is you often don't have a complete time series for those discards, and you would like to infer what discards were previously. And so we have a design document that we've been working on how we're going to implement discards. And that was really one of the beauties of working on a team across different science centers, is we had multiple meetings where we would talk about everything that each science center was doing at the moment with respect to discards, where one science center, just if you don't have catch of discards, they don't go into your model. Another science center, the retention curves and discard mortality parameters are used quite a bit. And then another science center, discards are so small relative to the amount of catch, then often discards just aren't worried about the same as other fisheries. And so hearing from each of the science centers on best practices within the science center, and then sharing that information around between all of the FIMS implementation team members, is really a pattern that we're trying to match for all future milestones and everything that comes into FIMS, where we talk about it as a group, and then a few of those that are extremely interested in it go off and then write a design document. That design document comes back to the larger group. It also goes out to other people that aren't on the FIMS implementation team to provide comments. And then it goes to the FIMS Council, which is an international body that we bounce ideas off of, and they provide guidance. And so the design document goes to them, and then it finally comes back to the FIMS implementation team, where we write the C++ and the R code to implement that. And then we have the case studies that we test stuff out on, and then we also push out like beta releases to allow people to test different features. And so there really is a long process for new features that come into FIMS. And so with this, I think, so I already explained the surplus production model, and we hope to bring that in around March of this year. And then we also have the CPUE model, where right now in FIMS, if you have a fishery that also has an index, so catch per unit effort data, you have to create an entirely different fleet for that index data. And this is just a design that as we get more complex, we see different things that need to be altered. And so we have the CPUE branch where we're going to allow you to have landings and CPUE information for a single fleet instead of having to split them out into two fleets. And then the TMB-AD branch and the discards have yet to be started, but we hope to bring the TMB-AD branch in beginning in February, and then discards will be a longer project that we'll start working on with the code probably around April. And then this map is really to remind us that we're standing on if you want to bring our version of it into FIMS. And so if you see in the center, we have future FIMS, and then I'll start with the black on the upper right-hand corner, where our next major task is to make FIMS relevant to managers is to get reference points and projections. So those values go to managers, and then they can use those to set catch limits or use them for relative measures, comparing ecosystem indicators, all kinds of things. Right now, we don't have reference points in FIMS. And so we want to work on getting reference points for each of the science centers, because each science center has different reference, not all of them, but there are slightly different reference points between the centers. And then we also want to work on a projection model, also done slightly different at each science center, and the information that the councils request are different. And so there's another project in the Office of Science and Technology that's working on projections, and so we want to work in tandem with them to bring in the best information that they're finding, and then to be able to code that so that FIMS can do that easily. And then before, I talked about random effects and how the random effects have already been started, but they're just not finished. And so we want to bring in different types of distributions that we allow for. And then with that, different types of random effects. So like on the lower left, we have the autoregressive, where you would have like an AR1 structure. And we also want to allow for a random walk. And here we're really looking to WAM, the Woods Hole Assessment Modeling Framework, that already has random effects that are implemented and being used for management. And so WAM will provide a lot of guidance here for that. And then we also want to be able to run Bayesian models, where it's maybe not extremely easy, but easy to go from an MLE to a Bayesian model. And again, this is one of those things where we don't want to have to switch frameworks to be able to do that. We want it to be easily integratable into STAN or some other MCMC algorithm to allow for a distribution of your parameters rather than a single estimate. And then a quite big undertaking that's in the works is the size-based model that's up in the upper left-hand corner. And so right now, FIMS is an age-structured model that also can fit to length data using an age-to-length conversion matrix. And with that, there's other kinds of size data out there besides length. And so we want to be able to have not only an age-based model, but also a model that's size-based at heart. So for species such as crab, they're very, very difficult to age, and the size really is the only thing that they can use for managers to be able to predict how many crab are out there. And they're the core, the models use a lot of the same equations. And so we want to be able to have some of those equations where, say, like the logistic selectivity curve, we shouldn't have to write that twice. You should just be able to use it in different parts of the model. But then there's other things like tracking how the crab molt, which is brand new to me. And so there's going to be a lot of new equations in FIMS as well to be able to track those kinds of things. And there's more than just crab. There's lobster and scallops and krill that have a really high turnover rate. There's all kinds of different species that we would like to be able to model in FIMS. So again, you can use that one modeling framework and build up different types of models. This project at the moment is at the informational gathering stage, where I have a list of different individuals that have been involved with some size-based models. So some researchers within the US, but also internationally. And then we hope to bring wants and some best practices, and then start moving forward in building some modules inside of FIMS that can run the size-based models. And I will say we've been working with researchers from the Alaska Fisheries Science Center that work with GMAX and a size-based model that's originally written in ADMB. And right now they're moving it over to RTMB. And that was a big push for why I mentioned earlier we have that TMB AD branch, where we want to allow those that are writing models in RTMB to use different parts of FIMS, even if you don't want to use FIMS as a modeling framework. Again, that logistic selectivity curve, if you want to be able to pull that out and not have to rewrite it yourself, we have to move to TMB AD so that different pieces of FIMS can be pulled out, just like an R function. And so, like I said, at the moment, GMAX is moving from ADMB to TMB using RTMB, and we're trying to help with that transition. And so if there's any other models out there that are also moving to RTMB, we encourage you to reach out to us to see how different parts of FIMS can also be applicable. And then I just wanted to give some links here at the end and bring it back to the overall FIMS implementation team. So in each of the hex symbols here, we have the different science centers, and we have 2 representatives from each science center, except the Northwest Fisheries Science Center at the bottom, because I used to be inside of that. And now we have to replace my position now that I'm at the Office of Science and Technology. And then on the left, there's some different links to get more information about FIMS. The first one is to the github.io site, and that is just overall information about FIMS and the kind of some about the timeline, but more just about the organization. And then the next link is for the source code, and I can put these in the chat in the end. And then we have there's a separate link for the C++ documentation, and we have the R documentation. And then we have a GitHub repository that just goes into our workflow as far as how we do development, how we communicate, and how to get into the code base and start contributing. And then we have a GitHub repository that has 6 case studies. So with that, I'll stop sharing my screen and take any questions.
All right. It looks like we've had one question come in the audience chat. Great talk and stunning slides, Kelli. Could you share more about the future plans for integrating ecological and economic information into FIMS? I'd love to hear about the potential timelines and strategies you have in mind.
Thanks, Bai. My first strategy is trying to become more of an economics person myself by attending a conference in California and just trying to get a feel from others that know a lot more than me how they think it should be done. And then second is trying to think more about how spatially explicit CPUE indices for fisheries are worked up, and trying to include the economics information into the data that comes into FIMS. So trying to think more about the data streams rather than adding an economics module onto the end of it. So also, and then those data streams situations going forward, how you think the economics are going to play out. And so for economics, it's really trying to learn more, where I know I'll never learn everything, but if I place myself where I know who to ask questions to, that for me is the most important part. And then second is to try to get our data to include some of the economics into it before we start thinking about how to add additional modules on top of it. And then with respect to ecological information, I think there's a ton of ways within our current structure and random effects and linking different distributions that we can bring ecological indicators into FIMS. But I really want to put a plug out for DSEM, dynamic structural equation modeling, and the work that James Thorson and Cole Monahan and Juliet, I'm very, very sorry, but I cannot remember your last name at the moment, postdoc were that into an assessment model, and then we'll that into FIMS. And with the DSEM, you can bring in multiple ecological indicators, and then right now they're putting that on recruitment, but in the future, they and FIMS would like to be able to put that, like if you want it on growth, you can make all of the environmental variables affect growth or other parts of the modules and just make it pretty amendable to how you think the life history actually operates.
Awesome. Thank you so much. Another question came in. It sounds like a pretty long pathway to get new features into FIMS. How do you balance adding new features thoughtfully with keeping pace with new research developments?
Thanks, Kiva. Everything is a very big balance. And as a new project lead of FIMS, it's a balance even trying to make forward progress and not just like put my head deep into books on how to be a leader or project manager. And I think at the moment we have a pretty good balance of trying to put in novel things versus bringing in structures that are tried and true and have been used for a long time. And the beauty is the branching system. So we can have multiple people working on different things in different branches. And just because it's not in the main branch doesn't mean it's not accessible, doesn't mean it can't be used for research, doesn't mean it's not going to have the same output. And as FIMS moves forward along in those branching structures that I showed, we have a lot of people on the FIMS implementation team. And we're trying to find a method that works best. But as we get more people beyond the FIMS implementation team, having that structure of you do X, Y, and then Z before it can even be brought into dev is really helpful. It lowers the barrier to entry for people feeling like they're going to mess up FIMS. If you're just pushing to a branch, you're not going to mess anything up. And so that's one thing where it lowers the barrier to entry on having branching structures. But second, there's so much testing that's there. And so you can have 8 different branches open, and if they're all being tested using GitHub Actions, we don't have to check things as much manually on the daily. And so I think the overly complex structure of bringing features into FIMS is not, I don't see it as a huge barrier to keeping up with research because we can have a bunch of different branches open. And I really encourage people to contact myself or other FIMS implementation team members and start your own branch. Fork FIMS, try to change some things, bring in the features that you want. But because it is structured on how you move forward once you have a branch with the feature, I think that it's going to allow things to move faster, move things through the pipeline quicker versus when you don't know how to contribute to FIMS, when you don't know what the pathway is to getting your newest and latest, greatest feature in there, then most of the time people tend to not contribute and we never get that information. And there's no way that the FIMS implementation team members can research everything or keep up with everything. And so I see it as my job just to organize those things and organize people that want to contribute. And so it might seem overly complex at the moment, but I think that it will really help when we get further down the line and have more contributors, so that I don't wake up early in the morning to a pull request and then panic, because that definitely happened with the first one. But now, like I said, with the pathway to bringing stuff into FIMS, I think it will be helpful rather than harmful.
Our next question, I don't recall if you mentioned the spatial extent of your model. Is it for a certain region or applicable anywhere?
Yeah, thanks for the question. The model can be used for any population all over the world. It has no spatial dynamics inside of the model, and there's nothing that prohibits it from being used in Australia at the moment versus the US. And so there's no regional capability. It is for one population. So at the moment, there's some infrastructure in there as we think about adding multiple populations to a single model. But right now, it's just one stock or population, however you want to define it, and then you get the output of the spawning biomass for that one population. And no spatial information comes into the model. The spatial information is all in the data that you work up. And so if you have spatially explicit indices, you can put those locations of space and where samples were taken, say, into VAST or SDM-TMB, and then you get non-spatial output. You get a single index per year, and then that would be what goes into.
Okay, next question. Great talk, Kelli. Do you envision FIMS providing support for MSEs?
A few MSE specific individuals on our FIMS implementation team. Catherine Doring is one of those individuals that I'm thinking about off the top of my head, where she was a developer, along with Nathan is also, I believe, what I like to call MSE experts. They developed SS MSE, which was a wrapper around stock synthesis. And then we also are talking to the NOAA MSE regional coordinators on how we can make FIMS move towards MSEs, and like what infrastructure we need to provide, what kind of information we need to provide to make wrappers around FIMS for running MSEs in an easier manner.
Next question. Thanks, Kelli. I'm wondering how easy it will be to extract information for data collectors from FIMS. For example, effective sample size, relative importance of data, different data types. Thinking of how we can inform survey planning decisions with assessment information in a streamlined way.
Yeah, thanks for the question regarding FIMS output. FIMS output at the moment is a combination of a lot of different things that we're trying. And so we have standard TMB output where you put your parameter vectors are in there, any derived quantity, and then you can run SD report on it and get the uncertainty about things. But we also have a JSON output format. And so you can, for each model that you run, you can create this JSON output, and then you can save that to your computer. And the JSON output has a lot more information in it, such as like the likelihood of each data point, some gradient information. That I didn't highlight in any of the releases because it's not officially released, but it is what we're currently working on, and we're trying to think about the best way to get all of that information out. And so there's two tables. There's one table of all of the estimates, and then we have a table for all of the input data, additional information that goes along with it, such as, like I said, likelihood information, gradient information, and sample sizes. I think this question is relating back to like data weighting and then getting at effective sample sizes. And we don't have a method inside of FIMS for data weighting. So therefore we don't really have output for that yet. But we are trying to think about passing not only parameter estimate information, but also data information back to the user.
Okay, next question. Will there be a mechanism to plug in user-developed specific functions, e.g. a growth model, for a specific model without adding it to the entire FIMS framework?
Yeah, excellent question. And this is where we kind of get back to the branches. So when you fork FIMS and have it in your own organization or your own username, then you can take and make additional models and put them in there. I don't know if we have tested someone compiling a plugin to be able to put that into a FIMS model. And honestly, I'm not sure how that would go. I can follow up with you as far as how, because you have the dynamic library and the .o and DLL files, and I don't know how we would get those to talk to each other if it wasn't compiled at the same time. But I'm sure where there's a will, there's a way.
Sounds good. Thank you very much. And that looks like all of the questions that have come in for today's seminar. And so I just want to thank you again for sharing your work with us, Kelli, and thank you, BI, for organizing this event. Audience, please join us again February 6th at 3 p.m. Eastern Standard Time for the next National Stock Assessment Science Seminar. Take care and enjoy the rest of your day.